Today we're going to look at the other side of proportions about testing hypotheses. In some ways, this is an extension of confidence intervals, but it takes a completely different sort of route to get there. So we're going to use this example throughout this. I made this one up primarily for Ian Wheatstruck, who was in my first statistics class that took this and ate at McDonald's all the time. So here's the story. You have a friend that loves to eat at McDonald's. In fact, he eats there nearly every day. But now his patronage may be at an end. Oh no. Last month, McDonald's had a promotion where with every purchase, they gave a scratch-off ticket, claiming that 1 in every 5 would win a prize. Your friend made 30 purchases last month, but only won 4 prizes. 1 in 5 should be 6 prizes. Does his experience give us strong evidence that McDonald's was not giving out as many prizes as they claim? You're going to see that phrase a lot. Does this provide strong evidence? Anytime you're doing that, see that, you know that you're going to test a hypothesis. Okay? Hypothesis testing is a lot like a jury trial. So the defendant has said, I'm not guilty. And that's where you start. You're supposed to start with assuming, no matter what the person looks like or smells like or anything else, that they're not guilty. Okay? And then you listen to evidence designed to change your mind from the prosecution. Okay? And the defense tries to refute that evidence. So, for example, if the defendant is not guilty, how likely is it they were found near the bank wearing a mask, running towards a car, and carrying a bag full of money? Right? That's not absolute proof, but it may be enough for you to be convinced. Okay? We start with what's called the null hypothesis, which in a jury trial is you start with the assumption that they are not guilty. In all these problems, we're going to start with some assumption. There's going to be some assertion. We believe the proportion of people who believe that space aliens in the form of lizards take over the governments is actually 4%. You start with that. Okay, that's your null hypothesis. This is what someone has asserted is true, and we're going to see if there's evidence to change our minds. In this example, it's that 1 in 5 people win a prize. So the proportion of people who win a prize is 20%. Then we go to the alternative hypothesis, which in the case of a jury trial is that the defendant is guilty. And in our example, it's that less than 1 in 5 receive a prize. If it was more than 1 in 5, we really wouldn't care. Right? So this is how it's written. This H sub 0 is read H naught. Okay? Naught is a really old-fashioned way of saying 0. Right? It was all for naught. Have you ever heard that phrase? His efforts were in vain?
Yes, I've heard that.
It was all for naught. It was all for nothing. That's kind of an old-fashioned.
Oh, is that where they get nada?
Nada? No, nada is nothing in Spanish.
Oh.
Although the words probably have some sort of historical connection or something. Our alternative hypothesis, H sub A, is that P is less than 0.2, where P is the proportion of people who win a prize. You got to set this up first. Okay? Now, we want to be able to apply a normal model to it. But before we do the same things that we've been doing on the last 2 chapters. It's got to be a random sample, or we need to believe that it's a representative sample. Each item needs to be independent of one another. We want to make sure we're sampling less than 10% of the entire population. We want to apply the success-failure condition. All of those things. And that's where this particular one falls apart. So the predicted successes is n times p, the number of trials times the probability of success. It's only 6. We can't be confident that this is going to follow a normal model because we just don't have a big enough sample. I say this kind of stuff all the time when someone tries to make a point about something. I'm like, your sample size is too small, right? It happens a lot. People try to make a conclusion based on a very small sample. Everybody does it to some degree. All of us are guilty of making assumptions based on too small a sample. And frankly, a lot of life experience, if we want to get into that, we have our own experiences, but in terms of the experience of people, our experience is very limited. And it's also very constrained by who our parents are, where we live. All these kinds of things constrain our experience. So that's part of being careful about judging others, is that their experience and your experience may be so completely different. Of course you ended up in different places, which is why it's important that you have a standard. We use the Bible as our standard, because then it doesn't matter what my experience is. This is what this standard says, okay? Rather than I'm just going to do what my experience says, which is part of the problem with relativism. I don't want to go off too far on a tangent on that, but because your experience is maybe very different, that's why people say my truth and your truth are not the same. What they're really saying is that my experience makes me believe this, your experience makes me believe that, and that's okay. And I'm like, yeah, it's okay that you have that, but truth is still truth. All right. Down off my soapbox on that one. Okay.
We should have clapped at the end. That was really
Probably
good.
just wrote it down.
I know, we should have taken notes.
So a few weeks later, your friend comes up to you, still convinced he's being lied to. He has now been to McDonald's 50 times and has only gotten 6 prizes. The expected number of successes is now 50 times 0.2 is 10, and the expected number of failures is 50 times 0.8, which is 40. Now we have everything we need in order to get the results if the actual percentage of prizes is 0.2. So the standard deviation in the proportion, notice this is not standard error because we know about the proportion. So the standard deviation in the proportion is 0.2 times 0.8 over 50. Take the square root of that. That's 0.057. Now, to find out how unlikely this is, there's a couple of different ways that we can do this. We can calculate a z-score and then use a normal CDF, basically use the normal distribution, and we can figure out how unlikely that is. Or we can just use the normal CDF, use just a normal distribution. I usually use a z-score because then I don't have to worry about labeling everything for the AP reader. There's fewer things to have to label. So the observed proportion, and that's not supposed to be a comma there, that should be 0.12, not 0,12. Then my z-score is my observed 0.12 minus what's supposed to happen, 0.2, all over the standard deviation, 0.057, and I get negative 1.404. That's my z-score. How unlikely is that? Well, you can use your calculator to find that. So, get out of that, just go to a normal distribution. You still don't have your calculator with you?
Well, I keep forgetting to charge it, but I'm gonna charge it tonight because Brody's gonna remind me.
I've got a reminder.
So we set it up as a z-score.
Duh.
We want the probability that it's less than negative 1.404. So negative 1.404.
Oh, look at that.
So is it very likely? No.
No.
But we get 0.08. So the probability is low, but it's not overwhelmingly low.
So it's not past 2 standard deviations.
You could use that as a guide. Yeah, it's less than 2 standard deviations away, so it's unlikely,
It's not possible.
but so we never get to things that are impossible.
So it's not.
It's not surprisingly unlikely.
It's not
Yeah.
strong enough.
Yeah, it's probably not strong enough evidence for us to change our minds.
What are we saying is not likely?
That McDonald's is lying to us.
Oh, okay. So we're saying it's not likely.
That McDonald's is actually giving out less than 1 prize in every 5.
Okay.
So this is how you would write up,
He's just getting unlucky.
yeah,
Poor Ian.
or maybe not. The story will continue.
Whoa. Cliffhanger,
Blah,
huh?
blah, blah.
So here's what you would say. The p-value is not low enough for me to reject the null.
Psychology. Okay.
I know, right? I was just thinking that.
This sample does not provide sufficient evidence to convince me that the prize rate is less than 20%. Okay? We call this probability the p-value. I wish they didn't use p for quite so many things,
Yeah, that's a lot.
but we call this the p-value.
So if it's less than 5%, because I know you could do the 2 standard.
Yeah, now we'll talk more about that later.
Oh, okay.
Just put a pin in that for the moment. Okay? And what's going to happen is that sometimes the cutoff line will be specified by the problem sometimes, or you will have to specify it. Most of the time we use 5%. So the phrase that actually I learned from my daughter-in-law's brother, that they used to use in his statistics class was, when the P is low, reject the hoe.
Always reject the hoe.
Okay? So if the p-value is really low, it's very improbable that it would happen, then we can reject the null hypothesis.
If it's low,
If the p is low.
reject the hoe.
Exactly. So that one just, it's so easy to say, and it makes sense.
It sticks.
So notice here, we do not say that we believe the prize rate is actually 20%. In fact, I'm beginning to believe it's not. Your friend's rate's only 12%. You're just saying there's not enough evidence to convince you. Okay? It's like when, someone says, "Oh, that person doesn't like me." Well, they did this. Oh, you're like, okay, they did this one thing. That's okay, fine.
Not enough evidence.
Right. Too small a sample size.
Duh.
We're back to that again.
Wait a second. How'd you get 12%? I thought we were at 8%. Did you get 8%?
Oh no, it's 1 in 12. It should be 8%. You're right. Your friend's rate is 8%, which is quite a bit less than 20%, which is what we're supposed to be getting.
That's one. I was just thinking, I was like, that's a mistake. Before we get it done, I should even.
All right, now,
Lock in, Brody.
so back to the jury trial, right? You start with the assumption that they're not guilty. If there's not enough evidence, then you say, okay, we find him not guilty. You don't find him innocent.
Yeah.
Finding him innocent is different than finding him not guilty. Okay? So when we're doing hypothesis tests, you either reject the null because it's so unlikely that we're going to reject what they said happened, or we're going to fail to reject the null. We never accept the null. Okay? You never accept the null. You either reject it or you fail to reject it. So this test is called a one proportion z-test by your book and a one sample z-test for population proportion by the nice folks at the College Board. So the story continues. Let's say that a month from now, your friend comes back to you with more evidence.
This kid, man.
He has now been to McDonald's 80 times in 3 months
Oh, diabetes.
and has only received 9 prizes. At first, you think his overall percentage has only gone down slightly. 9 out of 80 is 11.25%. It's only gone down, it hasn't even gone down a whole percentage.
That is like.
What is it, though, that makes this different?
Your sample size is way bigger.
Your sample size is now way bigger. As your sample size gets bigger, you should be, by the central limit theorem, closing in on the true proportion of the entire population.
So now I'm not a little bit stronger.
So, well, now we're going to check again the success failure. The assumptions and conditions have been met. Let's find the p-value for this. So our z is going to be our observed, which is now what? 0.1125 minus 0.2 over, what was it we're supposed to have it over? So we need to find out the new standard deviation. The standard deviation of p hat
You're thinking of last time.
is going to be 0.1125 times 0.8875 over, he's now done this 80 times. We'll take the square root of that. So, Jeff, all that into your calculator.
Negative 2.47? Possibly?
Yep, negative 2.47. I usually just go on until there's a good place to stop. The number of decimal places isn't super important. So now we can, and you guys know how to do that on the calculator. I'm going to do that on the TI in the interest of giving equal time. So clear that. Are you really awake?
So our p-value is
All right, so we go to distributions. It's a normal CDF. What's the probability that this is between negative infinity and negative 2.4768? And it's a z-score, so we're leaving all that stuff alone. Did you get 0.0066?
Yes.
So the probability that z is less than or equal to negative 2.4768 is 0.00, what was it? 68?
6, 6.
66? There's a less than 1% chance that this happened. This is a tiny percentage, right?
Wait,
McDonald's, man.
this is a less than one. Oh yeah, because
Yeah, 1% would be 0.001,
0.001.
and this is less than that.
3/5 of one, right? Around that.
2/3.
2/3.
It's 2/3 of a percent.
Okay.
So, what do we think now? We'll say something like this. With a p-value this low,
Check the hub.
we find, and what was the phrase way back up here? What did they ask us?
Reject the null? Wait, what?
When they asked the question? Where was it?
Oh, is it? How unlikely is it? What is it? Oh, wait, that's the wrong one. Given strong evidence? Is that what it
Yeah,
is?
where
It's
is,
like the top. The
so
last
the-
line on the first one. Does his experience?
strong evidence, okay?
Yes.
So, we find strong statistical evidence. I'll add the statistical.
They have to give you all points on the statistical.
That McDonald's is giving less than one winning ticket per every 5 people.
Do we say we reject the null?
Yeah. We are rejecting the null. And maybe you should say that up first. With a p-value this low, we reject the null and find strong evidence. So when you're doing this, you're always going to be saying, you know, I either find strong, you're always going to be talking about the alternative. I find strong evidence and I believe the alternative is true, which is this, okay? Or I don't find strong evidence to support the alternative. You don't really ever talk about the null other than saying you reject it or you fail to reject it. So you could take this a step further. I went ahead and did a confidence interval for this. And you end up with a confidence interval at 95% that is from 0.0435 to 0.1815. So based on this sample, we're 95% confident that percentage of prizes awarded in all is between 4.35% and 18.15%,
We're way below that.
which is below 20%.
Yeah.
All right. So your book cleverly called this next part alternative alternatives. So in some cases, we're not really concerned that the true proportion is less than what's been claimed, or that it's greater for that matter, simply that the true proportion is not equal to what has been claimed. Here our alternative hypothesis might be H sub A is not equal to 0.2. This is called a two-sided alternative.
So that would be just saying like it's not equal to 20%.
Right.
Then we don't have to.
We don't have to show whether it's more or less. We're just showing that it's not equal to. For a two-sided alternative, the p-value is double what it is for a one-sided alternative. It's just going to be twice as much.
Why?
Because it could be lower than or it could be more than.
Okay.
Okay? So, a study in the year 2000 estimated that the percentage of college students who were smokers was 20%. In a 2010 random survey of 80 college students, 24 were found to be smokers. Is this statistically significant evidence that the percentage of college students who smoke had changed? All right, we have to check to make sure that we've done all the things. So, is this a random sample?
Yes.
Yes.
Yes. This is a random sample. Maybe they said it was a random sample, as stated. $80 college students is less than 10% of all college students. In 2010. Expected successes. Is going to be 20% of 80, which is 16, which is greater than or equal to 10. And expected failures is more than that. It's 0.8 times 80, which is 64, also greater than or equal to 10. So the requirements have been met. For a 1 proportion Z sample, or a Z test, we'll say it that way, a 1 proportion Z test. Our null hypothesis is that P is equal to 0.2. Our alternative hypothesis is that P is not equal to 0.2. Now, let me show you where you can do this on your calculator. If you go to inference, notice tests, we looked at intervals in the last chapter. Here we can look at tests. It's 1 proportion. They ask you what is the null hypothesis? It's 0.2. What's the alternative?
Look at that.
And notice on this, you can pick not equal to as one of your,
Oh, Mr. Davis.
Oh, goodness.
on to next. So the number of successes, 20.
Why did I get 40?
I got 47.
20. I got 6.
What?
Where are you at?
What are you doing?
Yeah.
I did. 0.2 null hypothesis equals 0.2. Alternative hypothesis is not equal to 0.2.
Right.
Why does mine say number of successes is 6?
It preloads stuff. It has things in there. The number of successes is 20. 20 were found to be smokers. You've got to put it, yeah, you got to put it in.
Oh.
Confused. I was like, what?
Yeah, I didn't know what it was
Oh,
doing.
okay. Then what was the 16 that we got then?
That's the expected successes.
I thought like it was giving us the answer, so I was like,
So did I.
All right.